Okay, from today's class, I will be starting a new course which is named VLSI 1, stands for Very Large Scale Integration. Uh, this course will be taught in two parts, Part A and Part B. I will be starting Part A from today's class. In the Part A, the first topic will be what is VLSI, and second one is advantages and disadvantages of VLSI. And later, I will be following the syllabus according to my university or my lectures, my class lectures, obviously. Okay, so let's start. The first topic is what is VLSI, right? VLSI basically stands for very large scale integration. Very large scale integration. Before that, we all know what is IC, right? IC stands for integrated circuits. It's all about integrating a lot of electronic components in a single chip or single semiconductor material. I am assuming that we all have completed our electronics course, and we all have a good knowledge on semiconductor. I will be using this basics in this course because this course is designed for the level 3 students or level 3 electrical engineering students. So the students must have the knowledge about electronics and semiconductor. Okay. In our digital electronics course, we have learned logic gates. We have learned about combinational circuits. We have learned about sequential circuits. Combinational circuits means multiplexers, decoders, encoders, something like this. Okay. And sequential circuit stands for latches, flip-flops, and counters or flip-flops. Definitely a lot of flip-flops were taught in our class, which is D flip-flops, SR flip-flops, something like this. Okay. So this basics will be needing in this course, and I will talk about these topics a lot. Okay. So integrated circuits are nothing but an integration of many electronic components in a single semiconductor material. This is the core concept of VLSI, very large scale integration. What does it mean? Suppose I have my computer, which is Intel, which is consisted of Intel i7 processor. So let's say this is the processor that is integrated in my computer. Okay. So we all have seen processors. We all use processors in our mobile phones or in our computers, right? So in this processor, this is a very powerful element, right? It can perform multiple calculations at a single time, right? Okay. So it is powered by electricity and it can perform calculations and do mathematics and all other things together at once, right? So why this component is very much powerful and does all of these operations at a single time? There's a question, right? We all know we use an inverter to make one or high voltage to a low voltage zero. We, if we put zero here, at the input, output will be 1, right? So this is a calculation. This is a single calculation for an inverter. But in the real life or in the practical world, we need to perform tasks. We need to perform tasks which are performed by this gates or other electronic components like multiplexer, decoders, encoders, latches. Sometimes we need to store bits, right? So in flip-flop, D flip-flop, I'm talking about D flip-flop. If we provide a data 0, this device stores 0 for a time, right? These are basics of flip-flop. Okay. If we provide a multiplexer, if we have a multiplexer, let's say this is 2x1 multiplexer, this is selection line, and these are the inputs. According to this selection line, this multiplexer gives me an out, right? So let's say this is y. And these are the single tasks, right? These are the single tasks. Like I am giving him 0 and it's giving me an output. Similarly, I am trying to store a bit 1 or 0. This is storing a bit 1 or 0. But in practical world, we need to perform these operations at many levels. We need to perform calculations, multiple calculations. Let's say, for example, hundreds and thousands of calculations at once. How can I do this? How can we build a system which is very convenient for us, which is small, which is power efficient, which is portable? This is the question, right? So VLSI or integrated circuit trends does operate on this single concept. The idea is to combine a lot of electronic components like multiplexers, then gates, adders, subtractors, and many others. Okay. So if we need to perform these operations at once, or if we want to perform these operations in a single circuit, then we need to occupy them in a single semiconductor material to perform the tasks. This is what the concept is. We design a portable, a very convenient system that is called an IC or integrated circuits, which is integrated with many electronic components like adders or multiplexers, something like this, to combiningly make a very power efficient, very small, very portable device. This is the heart of VLSI design. This is the heart of integrated circuit design. So in my processor, let's say it is i7 12th gen. In this processor, these electronic components definitely are singly are integrated inside this single semiconductor material. So this is, let's say, for example, single semiconductor material or chip. This integration of many electronic components in a single semiconductor material is called VLSI, which stands for Very Large Scale Integration. This single semiconductor material might have billions of transistors, forming 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 a system to perform multiple tasks. So this is the core idea. Okay. So transistors, I have used a term called transistors. We all know what is transistor. Transistors, I will discuss these things later as the course progresses. Why transistors are used in VLSI design. I will discuss about this. So there is nothing to be tensed off. Okay. So the idea is totally simple. We have a single semiconductor material where we combine different different electronic components such as electronic devices, adders or multiplexers or something like this to perform greater tasks, right? So the core concept is integrating many electronic components in a single semiconductor chip or material to perform multiple tasks together, right? And by combining these electronic components, we make an IC. So this integration and the result of this integration makes and forms an IC, which is integrated circuit. And this total trend of designing ICs is called VLSI or very large scale integration, which means we will integrate, suppose, for example, millions and billions of transistors in a single semiconductor material to perform greater tasks. This is the core idea and the very basic level idea of VLSI. Why do we need this? Why we need this integration or making of electronic circuits or ICs? So let's say the question arises, advantages of ICs, right? ICs. And we have some very small disadvantages as well, which will be ignored because advantages are I mean, very much than disadvantages. So why do we need ICs? Because it is small, definitely, as we are combining millions and billions of transistors, but at a very small semiconductor material or chip. So which makes it small. This is portable because we all have seen our processors, right? How small this is, right? So we can say this is portable, this is small. As this occupies a very less space, it makes convenient for us to carry, right? So what makes it portable? This is very lightweight as it is small. Then we can say this consumes less power, okay? Consumes less power. Because we all know that electronic circuits operate on very less power, like 1 volt, 2 volt, or something like this. So this consumes very less power and fast, fast and convenient, definitely, for multiple calculations or multiple tasks, right? Okay. These are the advantages. The question might come, what are the advantages of ICs? Some disadvantages are there as well. As ICs are combined of millions and billions of transistors, this is to design, complex design or architecture. And another disadvantages of ICs are we can't use them for high voltage applications. High voltage applications, right? So we know that transistors and the other electronic components operate on very low voltages like 1.2 or 1.8 volts or something like this. So we cannot use them for high voltage purposes. Like Like if you say about a transformer operates in very high voltage, like 220 volt or something like this. But we cannot use ICs for high voltage operations. So these are the advantages and disadvantages which we have covered. Uh, so this is the core idea of VLSI design or IC design, or ICs or VLSI. In the next lecture, I will be talking about vacuum tubes and transistors. Thank you.